Hi everyone. So today I'll be speaking about my PhD, which is looking at predicting cancer vulnerabilities for drug discovery. And synthetic lethality is a well-known gene dependency relationship. For example, as shown in this diagram, there's a synthetic lethal interaction between BRCA and PARP genes. And in healthy cells, PARP inhibition does not cause cell death. However, in cancerous cells that have a BRCA mutation, PARP inhibition will cause selective cell killing, and this provides opportunities for precision oncology. And multiple myeloma is an important application area for my PhD. This is second most common plasma cell cancer, and the current 10-year survival is only 29%. And despite the advancements in therapeutics, almost all patients will develop relapse and resistance. Therefore, there's a need to identify more effective therapies. And my PhD builds upon resources such as SynLeg, and this is a web resource to predict candidate gene dependency relationships from multiomics data. So I've developed the MultiSEp package, and this diagram gives quite a high-level overview of the different functionality within the package. And there's a bigger image of this on my poster in the other room. But there's three main streams of analysis that can be performed, and all of these are adaptable and interchangeable depending on the input data. And there's 29 functions and 76 unit tests that have been developed within the TestSat framework. And I'll briefly talk through the multi-omics stream, and this can be done using an input transcriptomic data set. And the first step is to cluster the transcriptomic data. And this shows here for one gene, this gene called NXP4, it's been assigned to 5 gene expression clusters. And then the next step is to then perform statistical evaluation of these gene dependency relationships using the chi-square test. And an example of how this chi-square test is, or the contingency table is constructed, is shown here in the image on the right. And this shows in blue the different ablines which represent the cluster boundaries for the 2 different genes. And then the chi-square test will look to see is there a deviation from the uniform distribution. And then the next step is to then detect if there are synthetic lethal patterns. But this function can also look at other gene dependency relationships, such as enrichment for an induced dependency. And I've developed a computational workflow to then predict gene dependency relationships in multiple myeloma. And this was at genome scale for 27,232 genes and with over 370 million candidate interactions. And then we applied network thresholding. The first one was to plot the density distribution of the p-values. And this was then to eliminate predictions of things that we thought that were not predicted to be synthetic lethal. And this also eliminated quite a lot of candidate interactions. And then the second step is to perform the binomial test, and this then predicted a synthetic lethal network. And we then integrated mutational data within this network and predicted deleterious mutations to then try and identify what drug targets could be found from this network. And the network shown here, this is a synthetic lethal network. It has 1,466 genes and 5,245 edges. And the nodes within this network are colored based on the proportion of patients that would benefit from a drug targeting any of these genes. So those 20 hub genes in total that had a population coverage of above 0.2. So this means that at least 2% of the patients would benefit from a drug targeting any of these genes. And then there were 18 essential and actionable multiple myeloma targets that we found from this network. So in summary, I've developed the MultiSEp package to discover mutually exclusive loss signatures and multiomics data, which will soon be available in the next months. and generated a high confidence synthetic lethal network and predicted candidate drug targets and companion diagnostic markers for multiple myeloma. And thank you all for listening.
We're doing pretty well on time, so if anyone wants to ask any questions.
I'm not sure if it's on. Can you hear me?
Yeah, I can hear you.
I think it's one of the first times I heard in a talk somebody talking about unit tests. So maybe you can talk a bit about how you develop unit tests for your software.
Yeah. So I guess we've got 29 functions. So we're developing unit tests for each function to ensure that it's working as expected, as intended, So when we're adding new parts to the code or, changing it, then when we run these tests, it will, I guess, produce no errors, Yeah, and it's done with the TestSat framework, so it's quite simple to kind of automate that for each function for an R package.
Do you also start off with writing tests first and then you write the method around?
Yeah. So you'd write kind of like a use case of why you would do that test and what use that would be and kind of the expected output and things. So yeah, you would kind of write it down and then begin uncoding it. I guess that's maybe the easiest part, but
Thank you.
Thank you.